What's up, guys? Welcome to the second video in learning algorithms. My name is QDS Dani, and you guys watching my channel Koraiwood. Alright, so in the previous video we discussed why we need algorithms. We've seen algorithms in NASA, and we've seen algorithms in our daily lives. We've seen algorithms, why we need algorithms, why we should study algorithms. So in this video we're gonna see who invented actually the algorithms. If you guys don't know, this guy here, Al-Khwarizmi, is the inventor of algebra and algorithms. And this guy is a Persian mathematician who was there in Baghdad, and Baghdad was a city in Iran at that time, Abbasid Caliphate. And because Iran was the empire, and you guys might be thinking, well, actually Baghdad's in Iraq, and yes, it's in Iraq, but at that time, at year 825, that it was actually in Iran, because the Persians, if you guys don't know, the Persians has the 3005 here, 100 years old civilization. So it's a huge civilization, and the longest civilization in the human history. So they were the civilized before the Egyptians, even before the Egyptians. So they're very, very, very old. So if you guys looking from Jesus Christ all the way till now, is say 2000 years, and the Moses was like 3000 years, and these Persians was even before the Moses. They were civilized. They had a huge, very, very long civilization, and they're actually the inventors of many things like mathematics. If you go Bughali Sina is inventor of a lot of things. So, and Al-Khwarizmi is the father of algebra algorithms. So this guy here is actually the father of if you guys studying algorithms in computer science, so you guys know this guy. You guys heard of Al-Khwarizmi if we study algebra in high school or secondary school. We go see the algebra and algorithms. Alright, so because in this video we study algorithms, so we're going to start in the next video. We're going to go in technical part of algorithms. So in this one we're going to go briefly algorithm in our daily lives, why we need algorithm, our scope with the numbers. So our scope is getting bigger and bigger, and we started first with who invented algebra. So this guy is the inventor of algebra, and if you guys don't know, Intel was designed on algebra and algorithms. So the guy there in his garage, he designed exactly the chip, how the chip's going to work and how it's going to compute. That's exactly with the help of algorithms. So the Intel chips based on the algorithm and algebra. And actually in programming, if you guys know C++, Python, and if you guys good programmer and got a good command of programming, we know variables, equations, we assign things, and that's exactly with the algebra. So you guys know we do assignment, we do arithmetic, we perform all sorts of methods. We have functions, we have a graph, we have blah blah blah, and everything's we copy from algebra. Alright, so about the year 825, Persian mathematician and astronomer Al-Khwarizmi invents algebra and algorithm. He writes a book titled The Compendious Book on Calculation by Completion Balancing. It's called in Arabic Algebra wal Muqabila. Presented the first systematic solution of linear and quadratic equations. Okay, so this guy, he wrote this book and present the first systematic solution. So he presented the solution of linear and quadratic equations. So in algebra, you guys read this linear and quadratic. So we're going to show you guys what is linear and what's quadratic. Running times, what is big O notation, what is omega notation, and what is theta notation. So we're going to show you guys all these notations, asymptotic notations, and graphing and everything, sorting, analyzing algorithms, and how we're going to design our algorithms, our computers. Alright, so long story short about this guy, he was appointed as astronomer and head of library of the House of Wisdom in Baghdad. And as I said to you guys, at the time Baghdad was in Iran, and that was very famous city in the entire Iran, and everyone used to go there in the House of Wisdom and study mathematics and astronomy. And because the Persian was ruling there in Iraq, and the Persians was actually the parts of India and Afghanistan all the way to Uzbekistan, Tajikistan, Turkmenistan were part of Iran at the time. And if you guys want to know Istan means that the province in Persian. So because I speak Persian as well, and if you guys know that Afghanistan or Pakistan, our Uzbekistan, Tajikistan, Turkmenistan. Persian refers Stan as a province. So it means they're referring to one of their provinces, and because the Persians not as empire now, that's why the name is still the name. Ustan in Persian means a province, Ustan. So just remember that. So if you guys referring to Ustan in Persian, it means it's a province. Say Ustan Khurasan, or Ustan Isfahan, or Shiraz. So they referring to, say, provinces, our province. All right. So Al-Khwarizmi once said that the fondness for science has encouraged me to compose a short work on calculating by algebra wal muqabila. You guys know Persian or Urdu or Hindi. This very sounds familiar for you guys. Algebra wal muqabila. Wal means or, algebra, and muqabila means you guys come and set up, and muqabila in say you guys use in fighting as well, but this is not a fighting because that's mathematics. So that's how you guys see that, how you guys going to do the equations. Your equation on the two sides means the two sides going to be equal. So you guys competing like a competition is muqabila. So you guys coming in the mathematics, you guys putting your equations on the both sides. Like this side, if you're applying say the balancing on each side, so the each side of the equation, if you guys doing on the left, you guys do it on the right, you know, or if you guys want to solve something. So this is the concept was is in the Al-Khwarizmi's book called Algebra wal Muqabila, confining it to the what is easiest and most useful in arithmetic. So this guy introduced this algebra in mathematics for us to make a problem very easy. So how are we going to solve the problem? Say for example, we do it with equations, we do it with variables, we apply arithmetics, we apply parentheses around, we have rules and regulations, we have variables, we have polynomials, we have degrees in polynomials, we have a linear, quadratic, and blah 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 in algebra. So this video is not about the algebra, that's beyond the scope of this video, but this video is about algorithms. So we're going to study algorithms. So the word algorithm itself is derived from the name of Muhammad ibn Musa al-Khwarizmi, was Latinized as algorithmic. Alright, so in this slide we know now who invented algebra and who is the inventor of algebra. So we're going to go on the next slide. So algorithms in our daily lives, if you guys say you want to go for your favorite book in library looking for your favorite, what are you guys going to do? Method 1, look at every aisle till you find your favorite book. So if you guys looking for fiction book, or if you guys say you want to go about the simplest subject is if you guys want to go and find algorithm book. So what are you guys going to do? You guys enter the library and you guys go aisle by aisle every single book. So you go 1 2 3 if you guys looking here 1 2 3 4 5 6 7 8 9 all the way to here, it's like 50 books, and then you go 50 books, and then you go 50. Good luck. And I say again, good luck if you guys going to Hill Library, Cambridge Library, or if you guys, it's going to take you guys not months but years to finally find your book. And by the time, I don't know if you guys survive, if you guys look at every book. And we apply algorithm and we go method 2. We go first one is not a very good, it's going to take our worst case time is very big, so it's going to take a long time, nearly impossible. When we go jump on method 2 and we apply this one, look through book category to find your book. So easy, you go at the reception, you go and say that what book, computer science, yeah, that's fine, computer science here. And inside the computer science algorithms, and you go say the librarian, the book gonna say okay, the algorithms in the say aisle 24 at the right hand side, and this is the number. So you guys can, the worst case is that you guys might look for 10 books and you guys can find your favorite book. So the method 2 is very efficient, is very fast, and very good. The performance wise, you guys solve the problem in the method 2. Algorithm, we study how to sort and run things fast and efficient. As I said, to the method 2 is we already sort and run things fast and efficient. And the end, we see if we can do it better. And at the end, we can do it better. That's how we study algorithms. So if you guys look in computers, at the early computers, it took like almost size of the room. So it becomes smaller and smaller, because the computer scientist believes in the bottom here. It says, and at the end we can see what we can do to do things better and fast and efficient. So And I tell you guys, there is nothing worse than sitting in front of say computer, watching computer, and the computer is like say running like this. And if you guys are familiar with buffering in front of the video, that's the worst things in the world, because the performance was is one of the worst things. And you guys, I guarantee you guys going to leave that side or that thing. So it happens a lot, and it's becoming less and less, because all the computer scientists, they make the things faster and efficient. Okay, so the last slide, our scope, problem solving. So we're going to see how we're going to solve the problem and that scope. So our scope is, in the early ages, 1 2 was the biggest numbers, and people who used to live in caves, they were stuck with the 0 1 and 2, and they couldn't move forward beyond the 1 and 2. And when they came out of the caves and they started living in the cities, then the 5 6 and 10 became a problem. So they were stuck at the 5 and 10. They used to barter with the barter 5. I give you 5 bag of rice, you give me 6 bag of say dates, or you give me 6 bag of sugar. So that's how they used to barter. 10, and then 10 and 100. Then the humans moved to 10 and 100, then 1,000 to 10,000. So when the currencies and everything's invented, the scientists invented currencies, they went to 1,000 and 10,000, then millions, billions, and now it's trillions. So nowadays you guys hear that the Chinese economy is say 17 trillion, or American economy is say 15 or 16 trillion. So we all stuck at the moment on trillion, and I believe the humans are going to move on with beyond the trillions. They're going to go on the numbers which you guys can't even pronounce. Okay, so throughout the history, efficiency, scalability, and performance with numbers was problem. So in algorithm, we're gonna see efficiency, we're gonna see scalability, and performance with the numbers. So we're gonna see the 3 things. And if you guys look in here, the computers, the first early computers, we had a problem with all of these. Efficiency was not efficient, scalability was not, and performance was very bad. And when I started computers, only 300 websites, 1993, with 8-bit computers, very slow, extremely slow, with only kilobytes of memory. So that was the worst. So we could not, no one could imagine like getting 30 megabytes of memory from somewhere. So it was impossible at the time. And as the Moore's law, as the Moore got Moore's law, if you guys know the computer science, he explained that as the time goes by, the computer, the transistors getting cheaper and cheaper until it becomes very cheap, and the efficiency, scalability, and performance going to increase as the memory gets cheaper and transistors and everything gets cheaper. So at the time when he invented computer, the transistors, say that the material for the chip was say $5 a kilo. Then later on it becomes a $4 a kilo, then $3 a kilo, then becomes like $1 a kilo, then becomes a 50 cents a kilo, then it becomes like 10 cents a kilo, then it becomes like 100 kilos becomes like a 5 cents, then 1,000 kilos become $1. So the price went down, and the amount of transistor material, copper, whatever used for transistor becomes the quantity goes up and the price come down. So that's how they make faster, easier, and better chips. So the efficiency, scalability, and performance. So the computers, which we knew that the size of the room was become tiny and tiny and tiny and tiny and tiny. Nowadays you can see a small chip guys can fit inside the small mobile. TVs inside got a chips, everything's got a chip, even the cameras got a chip. Wireless mobile, there is everything you guys can imagine, it's got a chips. So the chips getting cheaper and cheaper, and the quality, efficiency, scalability, and performance getting faster and faster. And again we go to the what we can do to make things faster, better. Now we have a biggest numbers, like say Google have if you guys know Google is going to give you the search results. Say today if Google gives you say 100 millisecond, tomorrow Google's going to say try to do it in 80 milliseconds, then the next day, the next month or something, the Google is going to try in 30, the target's going to be the 30 milliseconds. So the Google's, the performance is getting faster and faster. Okay, so and this problem still exists. Now we have biggest numbers like Google. Do not confuse with the Google, because Google, the guys there's Larry Page and Sergey Brin, they went to they were after this name to go there, look there, because when they invented their search engine, they tried to name it to Google to fit that amount of websites, huge website, epic website storage engine, to search engine, so for the size of Google. And when they went there for domain name, they couldn't find, and then they decided to decide this one, Google. So they said that's fine, Google's fine too if you can't get Google. But Google is a number, don't confuse it with Google. Google is a very well known large number, equal to 10 to power of 100, or 1 followed by 100 zeros. If you guys don't know, this is a huge number. It's called it's also called, I can't even pronounce, 10 duo trillion, or 10 duo trillion, whatever you guys want to pronounce it. If you guys know the best pronunciation, just leave the comment below, then I'm gonna know that how to pronounce this. But whatever you guys want to pronounce, you guys can pronounce using the scale, using the short scale. So it's this number. If you guys looking one, and I try to put 100 zeros in front, so this is our scope nowadays. That's our problem that the humans face. And I've heard that the amount of atoms in this universe is 180 zeros at the front. So that's the amount of atoms. If maybe I'm wrong. If you guys think I'm wrong, you guys can leave a comment. If you guys know if it's 10 to say 80 zeros at the front, and that's what I heard. Maybe I'm wrong. If I am, you guys can leave a comment. Maybe I'll do, if you guys do your research and you can find out how many atoms in the universe. But what I heard is 10 to 0 and 80 zeros at the front. So that's how the amount of atoms. And I've heard another one that if you guys remove the space between the atoms in this planet Earth, it's going to be the size of Apple. That's what I've heard. So you guys, maybe I'm wrong. Maybe guys, you guys can do your research, but that's beyond the scope of this video, because we're going to see on the algorithms how we're going to solve our problems, how we're going to solve one problem stepwise, easier and better. And at the end, we're going to see that our motto is that efficiency, scalability, and performance. That's what we're going to the three things we're going to see in computer science, because we want things run efficient, scalable, and performance wise we want to see fast. Because as a programmer, we don't want to create something that takes a long time, and there is nothing worse sitting in front of a device or computers. If you guys want to sit in front of TV, you guys want to watch something and it takes ages, and this is things that used to buffer. This videos as used to go round and round, buffering, and you guys notice you guys don't see that anymore, because we have a fast performing mobile devices and internet devices and Wi-Fi devices. So everything's getting fast, and memory is becoming so dirt cheap that you guys can even buy the petabytes nowadays. Terabytes is very cheap, 5 terabytes, you guys. And at the 1995, if I would tell you that 1 terabyte, and you wouldn't even know 1 terabyte means, and that was impossible to imagine. 1 terabyte, even 100 gigabytes, it was very impossible to imagine at that time, as 1990s. But nowadays it's common, and you guys see that computers are ditching the 32 bits and they're going 64 bits. That's the standard computers. And if you guys looking for the next computer is going to be 128 bits. So that's what the computer is coming, because every time the Intel and all the chip makers, they multiply the chip. So the first one was 4-bit, then they multiply it by 2 and they make it 8-bit, then multiply by 2, 16-bit, then multiply it by 2, 32-bit, and then 64-bit. And if you go with this rate, you guys gonna know that they inside the chip they just multiply something. They just add say A, if it's A B C, then they say XAXB, then they say XAAA, then XAAB, then they use the number with the next chip. Then they use the numbers extra. They just use something, say XYZ, whatever then they want. They suits them. They just increase some, and they make, say if it's 4-bit, they make it 2, and they make it 8-bit. And when it becomes 8-bit, it becomes faster because it have a more room. And then become 16-bit, then it becomes even faster. Then if it becomes 32-bit, 64-bit, then the multi-threading is even becomes faster. It becomes efficient, and the performance wise, the performance goes up. and the amount of time, the worst case time that we know is comes down. So it becomes faster and faster. And now with the 64-bit, you guys run parallel threading inside the computer. You guys can run as many programs as you want. And I haven't got the 128-bit. Maybe if you guys do, and 128 bits computers may be a monsters, maybe performance wise, maybe they're going to be very fast, because as Moore's law says that the chips getting cheaper, the material transistors become cheaper, and the amount of price for the chips going to come down and becomes more and more fast. So performance wise, nowadays you guys see the computers at its peak. They're performing very well, and it's becoming fast because there is a high demand. So there's a high demand for efficiency, scalability, and performance in computer science. So that's what, as a computer scientist, this is gonna give you guys the best insight inside the computers, and it gives you the best knowledge for you guys to learn the computer science. Alright guys, that's it for this video. If you guys got any question or suggestion or comment, just leave in the comment box or send me email. Otherwise, I'll see you guys in the next video, and bye.